We're given the equation of a circle and we're asked to find the center and the radius. So let's write down the general equation of a circle. This is actually an application of Pythagoras' theorem, but you get x minus a all squared plus y minus b all squared equals r squared. So we're trying to write it in that form basically, and that's going to involve some completing the square. X squared plus 6x plus y squared minus 2y minus 10 equals 0. Just rewritten it to make the completing the square a bit clearer to see. So it's going to be x plus 3 all squared, halving that 6, and then minusing 9. So that is equivalent to x squared plus 6x. And then this is y minus 1 squared minus 1. That is equivalent to y squared minus 2y, but they're now in completed square form. Minus 10 equals 0. So therefore, it's going to go to that equals. So therefore, x plus 3 squared plus y minus 1 squared, because remember, I'm trying to write it in like this. I've got minus 20, so that is going to equal 20, which I could write as root 20 squared. So the center is going to be minus 3, 1, and r is going to be the square root of 20, which we could simplify as a third, but I don't know, they've not asked us to, so I'm just going to leave it like that. Okay, good little start there. We're then asked to find the coordinates of any points where this line intersects the circle. So essentially, I have a circle, and then I have a line, maybe going through it, maybe touching it, or maybe missing it, but presumably it's going to go through it at some point. And what we're solving here is simultaneous equations. We're interested in where the y values of both functions are the same. Essentially, when this is the same as this. And that's our method here, substitution. So it's going to be x squared plus, and then I'm going to replace y by 2x minus 3. I could substitute it into the earlier one, but I don't think there's any real benefit in doing that, because you're going to end up expanding that. So this is fine. Minus 10 equals 0. Expand this double bracket, so I'm going to get 4x squared. I'm going to get 2x times minus 3 minus 6x and another one, so minus 12x plus 9. Okay, just do it carefully. Okay, good, keep going. 5x squared, collecting the x squared terms, and then I've got minus 2x minus 14x, and then 9 and 6, oh, and minus 10, so that's going to be minus 1 plus 5. Let's just check. I think I've made a mistake somewhere. Yes, I have. It should be plus 10. Sorry, minus 10. Got to take a bit more care, don't I? So minus 12x plus 6x is minus 6x, and then minus 4x is going to make it minus 10x. Okay, and you'd kind of expect, I don't know, expect it to not be too bad. We're not too far into the paper. It doesn't say leave your answer as thirds or anything. So now I've got this common factor of 5. It's looking a bit nicer. Okay, but it's easy to make a mistake. That's the point I'm trying to make here. Right, I can divide through by 5 now. X squared minus 2x plus 1 is equal to 0. This factorizes to x minus 1 squared equals 0. So x equals 1 and y equals, I can put it back in, might as well put it back into the most simple one. 2 times 1 minus 3, it's going to be minus 1. So it did ask for the coordinates. I'm going to write it as 1 minus 1. In fact, it's just this one solution. And that leads us nicely into the third part. And if you've got two solutions in part two, which I may well have done if I'd carried on with my mistake, you might be thinking at this point, it's a little bit suspicious. State what can be deduced about the answer. And in fact, it didn't go through at 2 points. It only went through at 1 point. So it looked a bit like this. And this line has a special name. It's a tangent. So y equals 2. We don't need to do any more calculations. It's only one mark. Y equals 2x minus 3 is a tangent to the circle. Hey, brilliant.